Okay, awesome. Awesome. So welcome everybody. So I'm gonna cut off this. So my name is Dan Krutz. There we go. So I am from the Rochester Institute of Technology in beautiful, warm and sunny Rochester, New York. So like I said, we're about an hour and a half due east of Niagara Falls, about a 2-hour drive from Canada. And so if you like the cold and you like snow, great place to visit in the wintertime. Not, and it's, if you like, if you like warm, nice summers, it's beautiful here in the summer, terrible in the wintertime. And so I'm an assistant professor in the Department of Software Engineering at RIT. And today I'm going to talk about creating accessible software using experiential learning labs. And so if at any point anybody wants to get a hold of me, I've included my email address and the website to the lecture slides, or the website to the activity that we've created right here. A couple of things I'll mention, and I'm going to stop here for a second. So folks want to access these URLs, you can. But I've included a link to the lecture slides and the activity information on the site. I'd say probably the lecture slides are I would say those are sufficient. If you want to follow along, you can use those. But there's really nothing for the next 5 or 10 slides that you'll need to have access to or anything like that. There's really no heavy links that anybody will need to actually use, okay? But here's the set of lecture slides if folks would like them. So I'll pause for another 20 seconds. Okay. So a couple of things I'm going to talk about today is I'm going to talk about, provide a short introduction for the labs. I'm going to provide a short overview of the labs. And then I'm going to talk about the 3 labs that we've created, and then talk about accessibility and education, and then a general conclusion. So first and foremost, all the material that you would ever want to access through these labs is available on the project website. And so if you go to all.rit.edu, that will take you to the links to use whatever you want to use in today's session, or if you want to use this material in your courses, or if you want to learn more about accessibility. And so the other neat thing about this is there's really nothing for you to install. So I created this slide and I always have the saying that you can use the material only using your browser, nothing to install. I lied a bit. Actually, one of the activities, there's a Chrome plugin you'll have to use. So I guess I'm a liar. But in general, you can do all the activities through your web browser. So using Safari, Chrome, Firefox, you can use it via your web browser. So the accessibility learning labs, what are they? So the idea behind the accessibility learning labs is to make it easy to include educational accessibility content in your classrooms. So if you were teaching a foundational computing course, or even a course that was teaching students about computing that weren't computing majors, you could still teach them about why accessibility is important, and also some of the foundational skills to include accessibility into their curriculum. And so in these labs, I don't envision covering every accessibility topic that there is. That would be completely naive. That would be foolish to assume that. But the idea is to cover some of the largest accessibility topics, kind of the most predominant ones out there, and cover some basic foundational best practices for addressing these accessibility concerns in software that we're all creating. But the other goal I have for this is to really motivate students about the importance of creating accessible software, to have students know that you need to create software that's accessible, just like you need to create software that's, quote, bug-free or defect-free. That you need to create software that's secure. That you need to create software as a good UI. You need to create software that is accessible. And you need to create it because it's not only the right thing to do from a moral perspective, but it's also the right thing to do from usually a legal perspective. So every country is different, but at least the United States, if you create a piece of software that's blatantly non-accessible, you can be sued. So I imagine that most other countries around the world have very similar rules in place. So where to use these labs? You can use them in a traditional CS1 or CS2 class, an accessibility course, or in a general programming course. You can also use them in non-programming courses, so such as project management courses, and because the idea is that all people in technology should at least understand the importance of creating accessible software. The other is to include that this material can be used in outreach events and other camps. So really they have a wide range of applicable areas due to their ability to really be interacted with by a wide variety of folks that might not have a large set of computing skills, but also because there's nothing to install, then they're easy to adopt. So the primary background components are that the primary components of the labs are, we provide some basic background instructional material. So if we're talking about, if one of the labs covers color blindness, we might provide some basic information about color blindness, about how it affects usually, I think it's between like 8 and 12% of the user population has a form of color blindness. Then we'll talk about some of the main impacts of this disability. And so maybe it would make people who are colorblind, obviously they can't see certain colors. So if you create an application that's highly reliant upon colors and you're using a color that's not web safe to those colorblind folks, then they're not going to be able to use your software. So we provide some maybe 5 or 10 minutes worth of background instructional material. And typically this is in written format. Then we provide some lecture slides that the instructor could use. And then we also include a YouTube video of the lecture slides. We next include the actual activity, and the activity is very experiential based. So the participant will encounter the accessibility challenge, repair the accessibility challenge, and actually experience the impact of their repairs. The other is, the next step is that they will also be provided empathy creating material and then a concluding quiz. And we include the quiz because everybody likes quizzes, right? Who doesn't love a quiz? Raise your hand. All right, great. I assumed all of you love quizzes, okay? So just to kind of go a little bit more into the components. So basically we would have some of the background instruction, background material, and then we would actually have the student go through and use the inaccessible software. So this is an example of a participant using software that's non-accessible. So in this case, it would be non-accessible to a user who is deaf. And so what would happen is there would be an audio cue on the screen that if you were hearing, you could very clearly hear that audio cue happen. So whenever you need to click a button, it would play like a ping or something. But if you're deaf, you would never actually experience, or you'd never be able to experience hearing the audio cue, which means the software would be much less accessible. So the participant will experience that using some kind of emulation feature. In the case of a deaf hard of hearing activity, we might just simply mute the game. In the case of a color blindness activity, we would make the actual screen look like it would to be someone who is colorblind, and that's something you'll see in a bit. Step 2 is the actual repairing of the activity. So right in your browser, you interact with the software, and you'll actually repair the activity. So like basically in this case, you might actually add a hint or add some text-based content to say what the application is doing, what's going on with the app. And in this case, once the software is fixed, so like I show on this screen, once the user adds the text saying there's a hint on the page, then you could also add text there's no hint. So in this case, the user would experience the software in a more accessible way due to their fix. So the idea is that they experience software in an accessible way, they make the fix, and then they experience in an accessible software manner. And the idea is that they not only learn some foundational skills about how to create accessible software, but really more importantly, what they see is why it is important to create accessible software. What are the adverse impacts on the everyday user of creating inaccessible software? Okay. And so I talked about some of these steps already. And then the third component is an empathy creating component. It's some empathy creating material. And so what we strive to do is to create empathy for end users who have maybe accessibility challenges. And so we do that through videos, other readings, and through the experiential activity that I just mentioned. And so with the videos, what we typically have is a student of 18 to 20 years of age who they talk about how inaccessible software has adversely impacted their life. And so for like our colorblind lab, we have a student who's colorblind talk about how software that's not accessible to colorblind users has impacted their adversely impacted their lives. And I would totally advise everybody watch all the videos. And I think one of the videos has a student who is colorblind talking about their experiences buying a used car. And then when they went to buy the used car, the person selling them the car said, the car looks great. It's been no accidents. It looks fine. So the student who is colorblind bought the car, and they were very proud of it, only to realize that all the car's panels were all different colors. So like part of the car was blue, the other half was green, another part was a different shade of blue, but they never could actually tell because they were colorblind. And so like they were very disappointed when they got home, and their father was like, you bought a car that looks like garbage. Like, how did you not see this? And the student was like, well, I'm actually colorblind. It's a kind of an expensive way to find out. But I think they're very interesting to listen to these talks. And the idea is that these 4 to 5 minute videos drive home that inaccessible software impacts real people. And when possible, we use students of 18 to 20 years of age. So the participants going through these activities see how inaccessible software impacts people of their same age. And then at the end, we have a concluding quiz. And the idea behind this quiz is that it can demonstrate knowledge to the participants, so they can hopefully say like, yes, I learned something. I learned something about creating accessible software. Another avenue is for instructors. So if you ever wanted a mechanism to, grade a participant in a very loose mechanism, or if you wanted to say like, hey, demonstrate that you did the activity. Send me a screenshot of your completed quiz. Maybe that's your submission. That is a quick way to see if the participant actually went through and completed the activity. Okay. And so we published a couple papers on this. So I won't go through all the findings of the papers, but we did find the primary findings that I'll talk about today is we found the labs are effective from a statistical standpoint using a t-test. They're effective in informing students about how to create accessible software. They're also very effective in motivating students to create accessible software. Because again, I think the two are very important. If you have students that know how to create accessible software, but they're not very motivated, I think you're losing quite a bit out. So I think really you want to have students that have basic foundational skills about how to create accessible software, but they're also motivated to create accessible software. So they understand why creating accessible software is important. Okay. So I've been saying quite a bit. I've been talking nonstop for the last, 15 minutes or so. So let me pause for a second, catch a breath, and see if there's any questions that I can answer for folks. Okay. So what we'll do next is we will review a few of the labs. And so I think we're going to see how we're doing as far as time, but we're going to see if we can get through 2, maybe 3 of the actual labs. And while I'll leave the lab activity on my computer, I would hope that all of you are able to actually go through and do the activity in a fairly similar way on your own computers using the links that are provided. Okay. So the first lab is a hearing focused lab. And so the objective of this lab is to demonstrate the importance of creating creating software that is accessible to users who are deaf. So we are very fortunate at RIT because we are home to the largest technical college in the United States, maybe the world, that serves deaf and hard of hearing students. So our population has several hundred students who are deaf. And so we are very lucky to have those students on our campus. And the activity that you're going to use was created by a deaf student. And I think that is great because it not only enabled us to work with a deaf student, but the actual implications of creating software that's inaccessible deaf user was tested and created by someone who actually experiences the adverse impacts of inaccessible software to deaf users in the real world. So this lab will be a little bit challenging to demo because it is audio focused, or it is audio based. So I get that it's going to be hard for myself, who you may hear like a ping in the background from my speakers. I'm not sure, but you're going to have to be listening for short notifications on your computer as well. So let me go through. If you click on the link through here. So the URL, hopefully you can see this, is just all.rit.edu. Oh, I know that's covered up by this. So I'll pause for a second. And hopefully it can be taken, once you're on this page, can folks kind of give me a thumbs up? Okay, I'm getting Stuart, thank you. Thank you. Awesome. And you're cheating, Carolyn. You're on the call twice. So I was looking for the other Carolyn too. So, okay, so you're on the screen right now. And one thing I'll mention is that there are a couple little bugs to be working out in some of the labs. So you may see some font sizes that need to be changed and so forth. But like the text implies, what you're going to learn about in this activity is the importance of creating software that is accessible to deaf of hard of hearing users, and some basic principles about how to do that. And so what you're going to do is we're all going to play a game together. And it's a very, very complicated game where 4 random boxes will show up on the screen. And it's your goal to click on the correct box as soon as you can. It's all entirely random. So it's literally just a guessing game. But what will happen is sometimes in the middle of the screen, there's going to be like a hint area. And so what'll happen is whenever there's a notification played, it'll tell you to click on the hint area. You'll click on it, and you'll be giving a special hint for playing the game. Okay. So I won't read through all of this, but some of the things it talks about as far as background material is a case study on accessibility standards, validators, a National Association for the Deaf lawsuit against Netflix. So again, it's showing the business impact, the business necessity of creating accessible software. And then professional responsibility, about why from a professional's perspective, it's important to create accessible software. So I'll click next on this. And so like I just described, in this game, there's going to be 4 boxes that are shown, a large hint box, and then a timer for the game. So as you go through, and the quicker that you select the correct box, the better score that you get. Okay. So kind of the neat thing is once you play the game, you really can't do it too wrong. It's literally just clicking 4 boxes that they show up on the screen. So I'm going to start the game, and you see there's a countdown timer. And I randomly click the correct box. If I go through here, click on a box, I've actually got lucky twice, very, very good. So if I click the wrong box, you see here, the timer is going down, and I get a score. I was wrong here. If I click the hint box, there's no hint because I never received the audio cue saying there was a hint. So I found the right box there. If I click this again, there's no hint because my audio cue never played. But you can see my score goes up and down as I'm right and wrong. Okay, so a hint audio file just played for me. I don't know if you heard it over my speakers. And right there, it had told me what the correct box to press is. And so if you have your speakers on, you should hear a young woman saying hint. That means click on the hint box and it gives you the prize automatically. Okay, so I'll just pause for a second and let you folks go through that game. And I'll wait till everybody gets to a screen like they have here, and let's see who can get the highest score, okay? I'll send a virtual beer across the Zoom to whoever gets the highest score. Okay. So when you do get to the screen, just give a thumbs up. All right, thank you, Stuart. Okay, so who wants to volunteer themselves to the highest score? So who beat 325? I hope most people did. But who beat 325? So what should we go? Who got the lowest score? Let's try that. Who got the lowest score? The chat. Oh, I'm sorry, Stuart. I didn't see that. You got 650. So 2475. Very good. 1325. 1800. Okay. That's pitiful. 950. That's terrible. I don't know how you did so terrible on that. So what we're going to do next is we're going to play the game again. But this time the sound is completely off. So you won't hear anything. So whenever there's a hint, you're not going to hear any kind of notification. So the idea behind this is that it emulates what a deaf and hard of hearing user would experience from playing this game. I'll click next. And I'll let you folks play this along with me on your own computers, just because you know how the game is played now, and just don't expect to hear any hints. So when you get to the screen, just kind of give me a thumbs up. Thank you. Okay. Wait for another 10 seconds, 20 seconds or so. So how is everybody's scores now? If you want to put them in the chat, let's see how everybody did. Okay. So your score went down 950 to 600. Let's see how many folks went up and went down. 1,300 or 300. Okay. So it's looking like everybody's scores went down pretty drastically, which is pretty normal. It's always interesting to do these because every once in a while, maybe 5 to 10% of the time, you get a student whose score went up. And frankly, that's largely due to just the randomness of the game. But generally speaking, I mean, everybody saw their scores go down. And you played the exact same game as the first round. It's just this time you couldn't hear that audio hint. You couldn't hear that coming out. And so when the idea is that it drives home the fact that if your game was reliant upon audio hints and no visual aids, that it would adversely impact the experiences of a deaf of hard of hearing user. And one of the things we'll talk about with students is not only does that impact the experiences of a deaf of hard of hearing user from like an ethical perspective, but would they want to buy your software? If they were having trouble even using it, if they're having trouble playing a game or just using any type of application, they're going to be much less likely to purchase your software versus software that's maybe more accessible. And so that can hurt your business. So I get that it's very important to think about things ethically and legally, but it's also important, obviously, if you're running a business, you want to have as many customers as possible. And if you're creating inaccessible software, it's very likely to hurt your customer base. And so the next step in this process is to actually go through and repair the application. So you see some writing here about how it's interesting or why it's important to create accessible software. And then it's very important, the next step, click this repair button. Okay, so when you click the repair button, you're shown kind of this mocked out code editor. And the idea behind this code editor is we have some of the application code, faked application code showed here, but you can update these two areas. And so the idea is that in the software, if there's a hint box available, you would want to actually provide a visual cue to the user. If there's nothing available, you would provide the information there's nothing available to the user. So if I want to type in something about a hint being there, I would type in there is a hint. If I want to say there's no available hint, no hint, or whatever I want to type in. And again, this is just an example of a possible fix that the user could do to make their software more accessible. And from a coding perspective, it's not a heck of a lot. You're literally changing around, in this case, 2 lines of code. In your application, maybe it's a couple more lines, but it's not making a huge change to the code. But hopefully what we'll see next time we play the game is that it actually has a pretty significant impact on the user. So on a hit update, I'll save the code, okay? And once you do that, you should see something saying the repairs have been applied. And your button should change here to be start with the repair applied. So I'm going to pause for a second and make sure folks are at this point to start playing the game. So when you get to this point, if you can give a thumbs up, that would be helpful. Okay, thank you, Stuart. Okay, I'm just gonna hold on a minute. All right, so the next thing I'm going to do is I'm going to click the Start with Repair Applied button. Okay, so what I'm going to do next is now I'm going to play the same game again with a hint box disabled. I'm sorry, with the audio disabled, emulating what a deaf user experience. But as you can see here, it's got my little note I typed. There is a hint. So my hint is there, so I know to click on that. And there's no hint. So this is emulating what you probably saw in the first round where you heard a young woman say there was a hint or not. And so in this case, there's no hint. There's a hint. I know to click on that. Okay. And so I wasn't going super fast, so I got a final score of 300. So let me pause for a second, and I'll let you folks try the game again with your fix in place. And so when you get your fix in place, if you can put your scores in, if you remember what they were at the start, and then the first round, second round, and then this final round. Okay, so your score went up by a bit. And again, it's all randomized, so I mean it's that does kind of change your scoring a bit and what you're likely to get, but generally speaking, it should look like what you saw just there. So it actually went down. Okay. Carolyn is at 1925. What was your first? 600, 320, 600. Okay. So I think Carolyn's score, let me see. They went to 1325 to 1925. So it looks like everybody's scores were, kind of highest, they were high. Then they went low with the Inaccessible software. And then they went at least higher again with their fixes in place. So the idea behind this is with that simple fix you put in place, you were able to make the software easier to use. You're going to increase your scores. And so that fix, even in real code, wouldn't have taken that long to develop. That wouldn't have taken that long to implement. But it has a profound impact on users who may be deaf, who are deaf of hard of hearing. And so that could impact, like I said earlier, whether or not they buy their software or their experiences of their software, but also impacts things from an ethical perspective. Because if they're not able to use their software, you are being non-inclusive. Okay. And then so really the last parts of the game are it'll give you your score with a sound off, sound on, and your code fix in place. And so what I'm hoping most folks see is that they get a better score with their code fix and the sound turned on versus when the sound is turned off. Again, demonstrating that their code fix was good. And due to the randomness of the game and how the boxes are literally random, it's kind of hard to say this, but if you have a very poor fix in place, your score might not be very high at the end. So like if my messages were not very informative that I put into the code to fix it, maybe the user scores don't go up because I just didn't do a good job making the software accessible. Maybe I tried, but my messages weren't sufficient. So that is something to consider as well, and it's something that can be discussed with students as they interact with the software. And so what I could do is I could go through the application again, repair it, play the game again, or I could click next. And then this takes you to the empathy creating material, which contains information about what a hearing impairment is, and information from a real student who is deaf, hard of hearing, who talks about some of their negative experiences with working with inaccessible software. So I'm not going to play these videos right now. There may be like 4 or 5 minutes in length, but they're great to show your students or even watch yourself either at the start or end, I guess, of the actual activity. And so as you continue on, here's the actual quiz, which I'm not going to bore everybody in going through. And if you want to take it, you're welcome to. If you'd rather not, that is fine as well. But that pretty much wraps up Lab 1. So I should pause here and see if anybody has any questions they would like to discuss either in the chat or if you want to turn off your mic. Okay, so would folks like to jump to the other lab, or do folks need maybe a 5-minute coffee break or anything? I mean, put in the chat what you folks would like. Okay, so I guess we'll start with the next lab. So I get there by clicking on the Accessibility Learnings Lab logo in the upper right, or you could just go back to all.rit.edu. And in scrolling down, you can access the color blindness lab by clicking on the color blindness icon and text on the main page. So let me click that. And so this lab, like all labs, follow the same format where they talk about some background information about the accessibility topic being addressed. And then they describe some things about how it impacts users, what adverse impact it has, and how software can be made more accessible for those folks. And so initially we provide some basic background material. So in this case, it talks about the different types of color blindness and how prevalent different color vision deficiencies are. And so there are 4 types here, which I won't read through them all, but the type we're going to focus on mostly in this lab is a type that I cannot pronounce, deuteranomaly. Can't even pronounce it. But basically what happens is it'll make it so colors that non-colorblind users can see, like certain shades of green and so forth, will just look gray. You will have a hard time distinguishing them from other colors. Now, there are a lot of different forms of color blindness. It would be impossible to emulate them all, but we chose to emulate the most common one, or one of the most common ones in this actual activity. So I'll click next here. And so this is a very, very, very complicated game to play, even more complicated than selecting the random box. In this case, what you're going to do is you should click a circle when it shows up on your screen. So there's a blue circle here, and whenever it shows up on your screen, your job is to click on it. And you shouldn't click on other circles when they show up on the screen. So you lose points for clicking on those. but you click on this blue colored circle when it shows up on your screen. If you do that, you get points. If you miss the circle and click on a circle that's a different color, you actually lose points. So I'll go through and I'll start the game, get started, and we are working to change the color background of this. So the game is going to change. Okay. So as you see here, I only click on the circle when it's blue. Blue hasn't come up yet. And so I actually lied just there. So actually it was showing the correct color to click on in the bottom left there. And so you see here, I had a final score of 235. I correctly clicked once, and I correctly didn't click 13 times, and I missed that color of, it was like a reddish color once. So let's have you go through and play this game, and let's see what score you get. And again, what you should hopefully see is whenever you see that color shown on the screen, you actually click on it. So it's shown in the bottom left here. So it says whenever this color shows up, you click on it. Whenever the other colors show up, don't do anything to it. And 35, okay. $330. Okay. Okay. So I mean, everybody did pretty well. So kind of one of the interesting things about this game is that we've run this in front of maybe 400 or 500 students, and there are at least 2 or 3 that after completing this activity said, geez, I think I'm colorblind. So I think that's kind of interesting. And so everybody's scores are in the mid 300s, and that's pretty typical because quite frankly, it's an easy game to play. And so I'll click continue in the bottom there, and then it talks about some information about what a color blindness deficiency is and how color blindness can affect other people. So assuming I've read this, now what's going to happen is it's going to do the same game, but with a color blindness emulation feature active. So basically, whenever this color appears, I should click on it. So just like the same game I played. But what you'll see is that the colors should look very difficult to distinguish from one another because the page is made to look like how it would to be someone who is colorblind. So if you had this form of color blindness, this is what you'd be seeing. So again, I should be looking for this kind of pinkish color. And as you see here, it's very difficult to see. So if you see the 4 circles there, they all look the same color. And that's because the application has used web unsafe colors. So you see here, my score is really down. I get negative 565. And again, that is the same exact game, same exact form of randomness in the application that we played the first round. Okay, so let's have you folks go through and play this game, and let's see what scores you get. Okay, so everybody's scores, it looks like they're going down quite a bit. Okay, Stuart, that takes skill to be down 515, by the way. 800, wow, okay. So everybody's scores went down by quite a bit. And it's pretty easy to, I think everybody would agree that using that software in that format was really frustrating. I don't think anybody wanted to use the software, would want to use the software in that format. So what we'll do again now is we'll actually go through and fix the software. So I'll click next. And here it's going to talk about instructions about how to fix the software. And so what we'll do here is we're going to actually make the software more friendly to folks who are colorblind. And so what you can do here is you can actually change the color, and this is a little bit off with the Zoom sharing, but I can actually change the color of all the different circles. And so again, this is to emulate what a colorblind user would see. I'm sorry, what a developer would do to make the application, to change the source code of the application. And in this case, they're actually going through and making the software hopefully more accessible to folks who are colorblind. Okay. So one thing that hurt me, and might hurt all of you, frankly, is the fact that we didn't read the instructions on the last page too well. At least I didn't, where it talks about what some web save colors are. But when you're done with those code changes, you can hit submit, and you can play the game again and see what score you get. So I should be clicking this color when it comes up. So you can see my fixes were a little bit better. They definitely weren't perfect. Okay, so I did not negative 555 there. I got 155. So I didn't do as well as my first round, I don't think. But it's also because I probably didn't choose the greatest colors. So let me be quiet and I'll let you guys play the game and see what scores you guys get. Okay, so 230. So we went from negative 280 to 230. Okay. Okay. So 280, negative 55 to 290. 300. Okay. So it looks like everybody's scores are going back up to about what they were the first round. And so again, a lot of it is luck, and hate to say it, like if your finger slips and you click the wrong button, that'll hurt your score. But generally speaking, what your score is in the third round that includes your fixes, that should be indicative of the quality of the fix you put in there. So did you choose web safe colors? Because if you chose colors that weren't safe and were not accessible, your score probably wouldn't be very good. And so what we've seen from this is by creating the software in a little bit more accessible way, that it's going to be more usable to everybody. In this case, users that are colorblind. Okay. So in this case, we even have a leaderboard here. You can click I'm finished, and then that takes you to the end of the game. Okay. So let me pause for 1 second before we get on to the third and final lab, and I'll see if there's any questions that folks have. Yeah. So if it's a general questions, I think is that okay, Carolyn, to hold off until the after the third lab? Okay, thank you. Explain more about the color fixing. Is it only contrast? Not so much. So in this example, if I remember correctly, you are changing the actual colors of the game of the circles there. And so I think for some forms of color blindness, you might only need to fix contrast. But in this, I believe you're changing the entire color of the circles. Okay. Are there any other questions I can answer now specific to this color blindness lab? Okay. And the kind of last kind of piece of it from guideline for choosing colors. Yes. So there are a lot of guidelines for choosing safe colors out there. We do have one or two embedded in our instructions for the activity. I know I skimmed through that, so I'm sure you didn't get a chance to look over those. But there are specific guidelines. Seems there's so many different problems, maybe something that fixes it all. I think there might be situations of color blindness where there just isn't a fix that will work for everybody. But the idea is that if we can I think there are practices that can fix it for like 95% of the population. So there are some folks where, depending on the form of color blindness they have, you just might not be able to make software that's very usable to them at all. I mean, it'd be very challenging. You could do your best, but it's going to be challenging. But the idea is that there are some basic practices you can in place that will help like 95% of the users out there. No, thank you. Thank you for the nice words. Okay. Any other questions as far as lab, the second color blindness lab? Okay. So the third and final lab we're going to use, go back to the main page, is the accessibility with screen readers lab. Now this lab will be a little bit tough to do for really two reasons. One is that I'm going to have to open up Chrome in a second because there is a ChromeVox ChromeVox tool that you'll have to use, and I have a link to it. Yep, right here on the presentation. So I'm going to pause for 1 second. It's called the ChromeVox Classic extension. Now, this lab, I think, will work with any type of screen reader. It's just this is one we recommend. It seems to work well with a lab, and it works well with Chrome, which obviously a lot of people have. Chrome, I think, is available on basically every platform there is, and so that's one that we recommend. But basically, any type of screen reader would work with this, and so this is the ChromeVox Classic extension. And so I would just say take a minute and install that. And I'm going to stop my share for 1 second as I bring up my Chrome window. Okay. Okay, so hopefully, everybody can see my screen. Okay, so can you give me a thumbs up if you could see my screen again? Okay. Can you give me a thumbs up if you have the ChromeVox extension installed? Okay. 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 this out. Okay, let's see if anybody has. Does anybody need another minute before we continue on with the third and final lab? Okay. So this is going to be a little bit challenging for me to demo just because I have the screen reader active. And so I don't know if, are you able to hear right now the screen reader working on your end or no? Like when I move it? Okay, great. So I'm hearing it from my end. So it'll be a little bit challenging. Hopefully you all have the screen reader installed. And when you go through this actual page, and really any web page, okay, let me try that. Let's see if I can click. It'd be under, I assume, the settings. Okay, so stop sharing. There we go. Is that better? Awesome. All right. I'm sorry. Yep. So I tried the sharing thing, but I think I might have broke something. So I guess I'll go back to using the app. And so once you folks go through and use this, you're going to hear your screen reader talking in the background. And you may even see like how it's highlighting on my screen right now. You'll see that the screen reader highlighting that section of the page. And so what we do in this lab, again, like with all labs, is we provide some basic foundational information about the activity. So this lab activity focuses on how to make software accessible to users who are blind. And so if you're blind, that could mean you can't see anything at all, or it could mean what's called, referred to in the US as legally blind, where you have really tough, it's really challenging for you to distinguish certain objects on a screen. And so what an awful lot of people who are blind use are screen readers. Now, screen readers, like most pieces of software, are only as good as the information provided to them. And us as software engineers are responsible for providing good information to screen readers so then they can provide good information to end users. So in this activity, we provide information about screen readers, how they work. And in this activity, we're going to go through and play a game. And in this game, it's very complicated. It's going to ask you to click on the picture of like a cat or a dog or an ice cream cone or something very simple. So in here, it says, click on an image of a cat. Okay, great. Super easy to do. Click on the cat image. It says cat clicked. I'm the smartest person there is. I'm a genius. I can click on a picture of a cat. Next, it's going to be difficult to decipher what the images actually are, because they're going to be blacked out, emulating what a user who is blind would see. Now, in this case, the application is created in an inaccessible manner, meaning that it is not accessible to users who are blind. Where in this case, it's not using proper alt tags, which is a good practice for making an application accessible to users who are blind. So when going through this activity, you should actually have the sound up. And as you click on the different images, it'll just say image 1, image 2, image 3, image 4. So it's literally a guessing game for you to choose which is the picture of a cat. So as I'm clicking around, you have no idea what's the picture of the cat. So let me pause right here, and I'll let you folks get up to this point. So you should go through in the game and hopefully use it like a regular seeing user would, but then you would click on the application, interact with the application with the screen reader, using the software like it would be to somebody who is blind. So you can't see the picture of that cat to click on anymore. So let me pause here, and I'll wait for you folks to give me a thumbs up when you get to this point. Okay, thank you. Okay, does anybody need another minute before I continue on? Okay, so what I'll do next is I'll go through and I'll actually fix the software. And so a great thing to do when creating software, and I need to mute my screen so I'm not getting feedback. A great thing to do when for creating software that's accessible to users who are blind when they use a screen reader is to properly label the alt tags of images. And so alt tags, labeling an alt tag from a coding perspective is very simple. There's not a heck of a lot that needs to be done. But from a functional perspective, it's something that can really, really help. So in this case, what you would see is you can see the source code here. And what you would do is you would actually make the alt tags be something informative. So instead of just saying image 1, image 2, and so forth, what you would do is you would actually give it something relevant to the label. So here I see cat, car, burger, cow. So I might put in a cat, car, burger, and a cow. Okay. I would do that to update my code to have proper alt tags. I hit update. And now when you go through the actual game, if you've given things properly labeled alt tags, you should get a good sound. You should receive an audio notification of what that was. So in this case, I heard what a cat is, and I'll click on it. I clicked on it. Next, I clicked on the picture of a cat. So what I've done is I've made the software accessible to users who are blind. And again, from a coding perspective, it was very simple, but from an impact perspective, it was pretty substantial. And so to conclude the activity, we would have some instructions. You could actually go through and keep making code changes if you wanted to. But at the end, the application should be much, much more accessible to folks than it had been previously. So now that we've finished the third and final lab, let me pause and ask if there are any questions, any thoughts on this actual activity. Go back to my lecture slides. All right. So at this point, I would like to move into more of a discussion phase. So folks want to, feel free to actually talk now. I want to do as much listening as I do talking right now. So what I like to do is like I said, make this more interactive and to get feedback from folks. So first question is, let's start off with something negative. What is something you think could be improved with the labs, other than maybe some color schemes? I understand, but what are things maybe that could be done to improve these labs to make them more friendly to you to use, whether as a student or as an instructor, or do you think would be good for other students? What's something that we think we could do to help this better, to make these labs better? Okay, what are some things that folks liked about the labs then? I can start randomly picking on people.
So I really like labs.
What are some things you think you maybe liked with the labs or didn't like with the labs you would like to see built into future labs? Okay, so that they're game-based, the ability to change colors, fonts. Okay. Yep. So Stuart, the ability to change colors and fonts is really due to the fact that we are trying to make our educational accessibility material accessible. And so that is important for making software accessible to everyone. And the reason why it's game-based is because we're trying to make it, frankly, more enjoyable, more fun for the students, and we felt like making them game-based would do that.
I think if when we change the colors and we can see the result for what the color.
What do you think we could do to make this better, to make it so it would be something you might want to include inside of your classrooms or have included in your classroom as a student? No, I can't hear audio from the room. Hold on. go ahead. I'm sorry.
So
I had my sound muted because I didn't want my screen reader talking. I'm sorry. I'm sorry, Carolyn. Go ahead.
It is very noisy. I also have to uninstall it next.
Yeah.
Yeah, I mean, I think if you can make us see like what the colors will be like for the color-blinded people when we change the colors, it will help us like decide like how we design the color, right?
Okay. Okay.
And also helps with a higher score for the game.
And that is the most important thing, right?
Yeah.
Okay, thank you for that feedback. Other things you think you could be done to make it more, I guess you something you'd want to include. Yeah, yeah. I mean, the randomization of the first game is tough. I think making a little bit less randomized could be helpful. Okay. So are there any particular accessibility topics that folks would like to see developed?
What is there apart from hearing and color blindness?
So the other two labs that we're working on currently are dexterity and cognitive. So when I say dexterity, think of like how your hands work. So maybe you're a software user and you don't have any hands. Maybe you're like my grandparents where your hands shake a lot and you're trying to click on something very small on an iPad screen and you can't because your hand is shaking, right?
Mm-hmm.
And so that's dexterity. Cognitive, that's another one we're developing where if you're a user who has like maybe ADHD or another type of way you interpret things, I guess from a brain perspective, that would, impact how you can use the software and the accessibility of the software. Those are just two of the different forms of accessibility out there. There are a lot that I'm just having trouble thinking off the top of my head, but there's probably 5 or 10 different potential topics we could use. Okay. So kind of a question for you folks is how many of you folks teach? Oh, well, thank you, Justine. I guess, how many of you folks teach a class? Either TAs or, okay, Justina does, or as instructors, okay. Okay. So what could be done to make these labs be something that you would want to include in your classroom or something that we could even do to help include them in your classroom? So the idea is that if we could use these inside of a even a foundational computing course, a web programming course, obviously an accessibility course, or even an outreach event, like we've done these with our Women in Computing group at RIT. We'll work with like high school students. What is something that could be done? What could be done? What could be done? What could we do to make this maybe more attractive for you to include in your courses? Okay, so how many of you have included accessibility in any of your curriculum? I do, never. Okay, never. Okay, So it sounds like for Justine, it sounds like a an elective course. Okay. Okay. So one thing I kind and this is something that I want to be a discussion so people can chime in. Not as fun as this stuff. Thank you. So like one thing I wanted to bring up as a discussion point is this. So accessibility, I think, is a very important thing to include in software. We want to make software that's inclusive to everyone, just for being good people from an ethics perspective. But we also want to make software that's inclusive to everyone from a monetary perspective. Because if we create software that excludes even 5% of the customer base, that could be a lot of money. I mean, think about if Amazon.com couldn't serve 5% of their customers. That's like hundreds of millions of dollars or something like that. That's quite a bit of money. Couple that with the fact that something like 30 to 40% of all users have some form of a disability. And now when we think of disabilities, I think we think of somebody sitting in a wheelchair or something like that, but it could be color blindness. It could be tremors in the hands, something like that. And so quite a few users have accessibility challenges, but a lot of times we don't really do anything about it. We think about things like cybersecurity, which is important. We think about testing, which is important. But I think far too often we exclude fundamental concepts like accessibility from our computing curriculum. And I personally view that as something as being problematic. And I'm wondering what we can do with our labs to help address that issue. And what can we do to help you folks, address that issue in your classes? Okay. So I guess maybe the final things I'll mention, and maybe we'll end early, I guess, is that if you want to use our material in your classroom, please let us know. If you want to use our material in, well, thank you, Justine. If you want to use this material in your classrooms, please, you can go to the website and you can use it. It's all there on the web. We are making updates to it every week, so I'm sure you found some bugs and things like that. But more or less, all 3 labs are pretty close to being ready to go, or they are usable, as you folks saw. But if you want to use these in your activity, just go ahead and use them. If you want us to run any sessions for your class or any outreach events or anything like that, I'll put my contact information here again. Definitely please let us know that as well. I'm happy to run the activity. There's a great group of students working with me that can run the activity, so you all don't have to listen to me again. You can actually have somebody that's more enjoyable to talk. You can have one of my students that do a great job do this. They can give the session. So if you think you would like to include these in any of your classes, or we can help you include these in any of your classes, please, please, please reach out to me. Like, again, my contact information is located right in the screen here. dxkvsc@rit.edu. I'll put it right in the chat, I guess. So there it is in the chat. If you want to use any of these labs, please let me know. If you want to get involved with these labs, they're open source. So we're always looking for folks to work with, not only to make new labs, but to make these existing labs better. And we do all the hosting of the labs here at RIT. And if you'd like for us to run any of the activities inside of your classrooms or outreach events or anything like that, definitely please let me know as well. So are there any questions that folks have, I guess? Okay, so I guess that's really it for me. If folks want to hang around, I guess I'll be I'll be the last one on a Zoom call, I guess. As long as folks have questions, I'm happy, or we just want to chat, I'm happy to do that. Otherwise, I guess I'll let everybody go. And if you're in the US, it's past lunchtime. And if you're anyplace else in the world, get something great to eat there too, okay? Awesome. So thank you, everybody.
So Daniel,
Yes.
I was wondering if there are like linters for accessibility.
There are what?
Linters that like
Oh,
check your
linters.
web code automatically
Yeah.
and tell you, oh no, you shouldn't do this.
Yes. So there are some tools out there that will identify some inaccessible piece of software. I don't recall them off the top of my head, but there are definitely tools out there that will help. Um, I have a cybersecurity background, so I'll say it's analogous to cybersecurity in the sense you can't run one tool to check for all of your vulnerabilities. And you do have to build it in from the start. But there definitely are a lot of tools out there that can help.
And are there people looking into automatically repairing these accessibility things?
This is a guess on my part. I'm guessing that there are, but I'm not a great person to ask that actually, or answer that. I mean, I'm sorry. And I did find out the town where my friend's wife is from. Let me send you the. I'll put the link. I'll put the link to that town in the chat in a second.
It was nice to hear that you're from Rochester. My uncle lives in Rochester.
Oh, really?
Yeah. He's a maths professor at, I think, the same university as you, but I don't actually know exactly.
He's math?
Mm-hmm.
Okay.
Yes. But I have been to the Niagara Falls when I was very, very small.
Let me put the town. All right, so I just put the town in the chat window.
I have no idea what this is.
It's very tough. It's near it borders Lake Constance near the Austrian-Swiss border.
Yes.
And so what happened is my friend's mother-in-law, she grew up in a small house in, this area where I can't even say the name. And so her family moved to the US when she was like 18, moved to Rochester. Right. And then she was about, 25 or 30 years old. She says, I'm going to go back to see my family home, in Germany. Right. So she went back home and, met the family who they sold the farm to. They weren't related to them at all. They just sold the farm to a bunch of strangers. And she ended up marrying the boy who bought the farm. And so she married back into their farmhouse. So she moved back. So when we go to visit them, they have Rochester accents. They sound like they would be great spies. I mean, they're 100% German, like the mother and all of their kids and the woman my friends married. I mean, they sound like they're from Rochester, New York. They have no accent whatsoever, but 100% German. So I just think that's a cool, kind of romantic story. Like, it's like from a movie. Like, I'm going to go back, visit my family. Then you end up marrying the guy who bought your, son who bought your house or whatever. Yes. So I think that's cool.
So sweet. Okay. Nice tutorial.
Oh, thank you so much, Caroline.
I liked it.
Yeah, nice to meet you too. All right. I guess bye, everybody.